So from that, I'm going to introduce you to our speaker for today, Levi Button. He heads a lot of our technical and training on the West Coast, and he's going to walk you through Viswalk basics at more of an introductory level. Levi?
Thanks, Sean. Welcome, everybody. Thank you for joining. We're going to go ahead and get started talking about the basics of Viswalk. All right. Sorry, I'm waiting for it to switch over here for a second. Sean, are my slides changing? My preview doesn't look like it's changing at all.
I see the agenda slide right now,
good.
and I did see you go one slide forward and back.
Okay, yeah, my preview just wasn't working. All right, so with regard to the agenda today, what we're going to be talking about is the Viswalk components. So what does it take to build out the model network? We're going to talk about vertical circulation, so adding different levels and floors to your pedestrian networks. And then we'll be looking at evaluations as well. So what kind of tools do we have to evaluate or pull data? What kind of key performance indicators are we going to be pulling out of our models? Now, before we get too far into Viswalk, what I did want to mention is we'll be frequently mentioning the word Viswalk a lot, but Viswalk is just an add-on tool to Vissim. It's the pedestrian component, simulation component in Vissim. So if you already have a Vissim license, you can start building Viswalk elements like ramps and obstacles and areas and things like that. You just might have a limitation on how many pedestrians you can simulate at one time. So when we say Viswalk, we're just talking about the pedestrian specific components in a Vissim model. We do have a standalone Viswalk software package, but more often than not, people are wanting to use it with paired with the vehicular simulation of Vissim, and so it's a Vissim add-on component is what we're going to be looking at today. Okay, so the first place we're going to start looking at is model components. And what we mean by that are, what are the physical components you need to start building a network? For those of you that are familiar to Vissim, these, you'll start with links, you'll put in routes, you'll put in vehicle inputs, things like that. We're going to talk about what elements like that are involved in building out a pedestrian model. So the first component that we're going to look at is the pedestrian area. Now, a pedestrian area, this is the primary walking space. It's essentially the links of the pedestrian space. Unlike a link in Vissim, which has directionality and basically linear flow to it, a pedestrian area is a geometric space, and the way the pedestrians navigate that space is by finding their own optimal route from one position to the next. And so what we need to do is build out objects that provide geometry or boundaries for pedestrians to be able to walk in. And typically these are going to be floors, but they could also be sidewalks, or you can even put them under as shared spaces for streets and things like that. Additional uses that we're going to be looking at in addition to that, areas have different uses. So in this image, you might see the purple areas or the blue areas down below, where they're acting as platform edges for public transit or waiting areas. You might also have waiting areas for things like kiosks or turnstiles or elevator waiting platforms and things like that. So what I want to do is I want to first get into Vissim and start showing you what it looks like to build out our pedestrian areas. And just keep in mind, before I get into this, I'm going to be building these out manually, but you can also use CAD files, DWG, BIM, or shape files to import your pedestrian areas. So if you already have a architectural design or site plan or something in Revit, you can bring that in and it will automatically build out all these pedestrian areas. So let me jump into Vissim. And here I have Vissim 2022 open. I'm gonna just talk through it for a quick sec. Right now we're looking at a specific public transit platform. This is in Portland. I like this one just because it's open to the air so we can see the different levels. All right, so looking in Vissim, if you've used Vissim before, you should be familiar with the layout of the network editor and the network objects. And where we're going to be looking is these yellow objects at the bottom of our network objects listing. And the first one we're going to be looking at are the areas. Now, when you build out pedestrian areas, the first thing you're going to do is you're going to find all the major walking areas that people are able to walk in. So for example, we might have this platform down below. So I might draw this platform out that looks something like this. So now I've defined a platform edge. And if we want people to walk between platforms, so for example, there's a rail in between, so I might have another platform on the other side. What I'm going to do is I'm going to build out the major study areas that I want to look at, which might be these platform edges. And then if I want to connect the two, we just need overlapping areas between them. So for example, I might draw an area that kind of walks around like this. And so this might be a hallway, it might be a staircase, it might be something like that. We'll look at stairs in a little bit, but basically to make it so that there is walkable connections, all you need is some sort of overlap between the areas. And now that we have our areas connected, we can start navigating people between them, right? So if we're gonna build out our transit center, right, we might have the platform levels down below. We might have a larger area up above that might look something like this, and maybe it follows the curvature of the road a bit. I'm just going to do this really quick. And maybe we have these different areas that look like this, and now we just need to make sure that we can connect them, right? And so I might start with some dummy areas that look like hallways or something like that. We can also switch from polygons to rectangles. And so that will make fairly standard rectangles. You can also create circles. So if you need to create a circular area, you can do that as well. So again, the pedestrian areas act as the walkable spaces. So you don't need to worry about drawing in the walls or anything like that. They'll see the edges of the areas as walls. So you can kind of avoid the walls in that situation, or the curbs or the edges of the street, or what have you. All right, now that we have our pedestrian areas in place, or at least our basic level pedestrian areas, the next thing we're going to talk about are pedestrian obstacles. Now, pedestrian obstacles are negative areas, basically, is the way I like to think about them, right? These are, you'll draw them and create them and import them just like you would a pedestrian area, but they act as obstacles or places that pedestrians specifically can't walk. In particular, like I said before, you don't need to worry about building out the walls using obstacles necessarily. These obstacles are typically going to be things that are centered within the area. So these can be benches, columns. In this picture that you're looking at here, we have a security terminal in the middle. We have turnstiles. We have separation between different security zones with different walls. And so that's what obstacles are generally going to be used for. Let me jump over into a completed model that I have. This is Farragut West in Washington, D.C. By the Washington Metro. This is a subway station, and what you can see is we have all of our pedestrian areas that are mapping out, you know, the street level entrance, and then we have this mezzanine. And then here's our security concourse. These are all 3D models that we brought in. But you can see that we have, if I turn off the areas and turn off the 3D objects, you can see we have a couple obstacles that are just kind of hanging out here that are acting as kiosks or walls, or maybe we have benches down below that are making pedestrians avoid them. So again, you'll draw out your obstacles to act as negative space that pedestrians have to avoid. So in our transit center model here, if I switch over into wireframe mode, you might see some things like these grass areas, right? You don't want people walking on the grass areas. I could draw all of these sidewalks out as individual areas, but if I had for example, an architectural design, a layout of the greenways and things like that, I could also just draw these as obstacles. So I could create an obstacle here and give it a height, give it an offset, things like that. Click OK. And now we have our larger pedestrian area. And you can see now we have an obstacle in the way that will help pedestrians avoid walking on the grass and what have you. Again, some people prefer to also draw out the walls, but you don't really need to do that because the edges of the pedestrian areas will act as walls themselves. So if I go through and I just draw a couple of these, I'm not going to draw every single one, right? You might do some landscaping as obstacles, right? We might have some trees. So here for the base of the tree, I might add a new obstacle and I'm going to do a circular one for the trunk of the tree, right? And so in that case, pedestrians would avoid the trunk of the tree. We have light poles that people might be avoiding. And then we might have things like these shelters. Don't want a circular one, but maybe we have some of these shelters that also act as obstacles, right? And so you'd build out the walls of the shelter because it's within the larger pedestrian area, right? So you can draw out these negative spaces for things for pedestrians to avoid using obstacles. All right. Moving right along, after you've built out your walkable spaces and your negative spaces, the next step is to start putting in pedestrians, right? And so in this case, it's going to be very similar to static assignment in Vissim, right? So you're going to have your vehicle inputs. In this case, you're going to have your pedestrian inputs, and you're going to have pedestrian routing that we're going to be defining. In our case, what we're going to do is place a pedestrian input on a specific area that will make that area act as a pedestrian generator. If I jump over into my Farragut West model, you'll see we have this green area up above here. What this is actually showing is that we have placed a pedestrian input on that location. If I go into 2D mode, you can see that we have our pedestrian input placed on this area, and that flags this area as a pedestrian generator. So what's going to happen is we're going to place a pedestrian flow on that input point, and it's going to randomly generate pedestrians throughout that area. And so you can see we have another one over here on the east side as well. So in our model that we're building out, we might place a pedestrian input on this larger space to generate pedestrians. That is totally okay. I just hold control and right click, and now this larger space starts generating pedestrians. But a more common way to do it is to look at where are the actual access points to the network. So for example, we might create a dummy area towards this end because we have this sidewalk that people might be walking up to the station from. So I'll create a quick dummy area there, and I might put a pedestrian input on that space. And so instead of having pedestrians randomly generate in this very large area, which could create very different travel times depending on where they generate, I'm going to kind of centralize where they generate from so that way the travel times are more consistent between the pedestrians. Another area might be this parking garage. And so I'm going to place a large pedestrian area right here, and then a pedestrian input on the parking garage. And then finally, we might have a sky bridge. Here, I'm just going to place a dummy spot like this on this corner and pedestrian input at that location. So again, I am placing my pedestrian inputs on pedestrian areas that I want to generate the flows coming from. Just like you would do with a vehicle input in Vissim, you're also going to define different pedestrian types. Now that could be adults, that could be children, that could be ADA considerations, that could be non-ADA considerations, right? And so in this case, depending on what types of pedestrians you have, you can create different compositions to simulate that. It could also come down to, you might have commuters and tourists, or maybe you have background pedestrian traffic, like commuter traffic versus event traffic. If you're modeling something like a stadium, there might be a bunch of people getting on the train to go to the stadium specifically, as opposed to commuters maybe going the other way in the evening, maybe during like a weeknight game or something like that. Once you have your pedestrian inputs in place, the next thing we're going to do is we're going to be placing static routes throughout the network. Now, I say static routes because what we're going to be doing is specifically defining a route through the network, but unlike the static routes that you're familiar with in Vissim, the static routes in Viswalk are going to be a little bit more like dynamic assignment, because what you're going to do is you're going to be placing static routes as origin destination routes. In this first image, you can see we have a static route going from the platform edge all the way up to this western exit. And yes, there will be intermediate stops in between the origin and destination, but generally what you're going to do is you're going to place a static route with a decision point that will say, okay, we're going to platform A or platform B, or we're going exit A, exit B, or concourse A, concourse B, concourse C. And you're going to be defining those flow rates. And then the pedestrians are going to find the optimal path to their destination. So you don't have to micromanage the pedestrian pathing. You just have to tell them where to go. Now, in between, we might have some tasks or events that we want the pedestrians to be doing on their way to their destination. So think, okay, you get dropped off at the airport, right? You're dropped off at the curb. You might know where your gate is already, but before you get to your gate, you have to go check in your bags, and then you have to go to security, and then you might stop at some convenience stores or kiosks that are in the concourse once you get through security, right? I would consider all of those events as partial routes, right? Your static route is curb to gate, but your partial routes are all those intermediate activities, security checkpoints, concessions, ticketing, things like that, that you'll have to work through. So if we jump into our Farragut West model, right, we might have a static route that traverses from the entrance. Don't want to do that. Here's our static route decision point. So here we have a static routing decision point that is taking somebody all the way down, in this case, to the security concourse, right? But you see that we have them stopping here, and then you see that we also have an intermediate point that was at this location as well. And the reason for that is because we have now intermediate routing decisions that say pick one line or the other, right? Or we might have them say go to the left or go to the right. So in this case, we're going to have intermediate stops on our journey. For something like a subway, that's fairly straightforward. In this case, it's just which one of these queues are you going to be joining? And then once you've joined that queue and navigated that security checkpoint, you can get down to your platform. For something like an airport, it might be a little bit more complex because there's more things that you have to do on your journey. So for our platform here that we have, our static routes, we're going to select pedestrian routes static, and we're going to place a decision point here, and then we're going to place a destination on our platform on the north side and the south side platforms. And you can see when we place the destination, they turn red. And then just like in Vissim, we can define relative flows. These can be pedestrian counts, or they could be weights that you would assign. So maybe 150 people go to the north side and 225 people go to the south side. And so you'd go through and you'll define all of your static flows from each one of these locations. Now, if we had an intermediate point, so for example, here, there is like a coffee shop. So what we'd do is we'd place a area at that location to represent that coffee shop. And then once we have that area represented, or that coffee shop represented with an area, we could take our routes and we can place an intermediate point on that area. And so this will tell pedestrians, before you go to this destination, go to that coffee shop, right? But in order to do that for all of our routes, we'd have to tell every single route to go to that destination. So a much more, and not everybody would want to go to get the coffee, right? So in this case, what we might do is we might actually put the intermediate point on this larger area, this larger concourse in between. And what that will do is now we can place a partial route on the concourse itself that says, okay, if you're going to the concourse, some of you are going to this southern platform, and a certain percentage of you might go to the coffee shop, and the other ones are going to go directly there, right? So in this case, it might be 10% and 90%, right? So 90% are going directly to the platform, 10% are going to the coffee shop. And what this partial route will do is say anyone who steps onto this area or has a decision point on this area will now decide whether or not they want to go to the coffee shop. And so that way you can kind of scale up your routes. So if we go and add in more routes later, all we have to do is navigate them to this location. This would be something like coming in from the curbside at an airport, coming into the ticketing concourse and deciding, do I need to get, can I go directly to my gate, or do I have to first stop and check a bag? And so that's kind of what the partial routes are looking like there. All right, once we have our basic areas set up, we have our basic structure, we can hit play on our simulation. But if we look at our model, right, this is, the platforms are not at the same level as the street. In this case, they're about 20 feet below, they're sunken grade, right? And so in this case, what we can do is we can create some vertical separation between them. And there are different ways that we can do that. So we're going to talk about how we can control and operate vertical circulation. The first thing that we're going to consider is how do we actually get the areas separated? Now, if you've used Vissim in the past, you might have used the Z offsets for things like gradients and the like, or in the links, you just put in the gradient percentage. Well, in Viswalk, when you're using the pedestrian tool, you're really going to want to use these offsets and levels. So the first thing we're going to talk about is creating base levels, which give you a default offset that you can use so you don't have to offset all the vehicles to the same thing. The other thing that creating different levels will do is also allow you to create different security zones and things like that, because the only way to traverse between one level and the next is through a ramp or a staircase. So that reduces how many walls or obstacles you actually have to create. So for example, if we look at our Farragut West model here, we have 3 different levels. We have the street level, we have the mezzanine level, and we have this platform level. If we look at any particular area, the Z offset of a particular area is 0. But what we can see is that these areas are definitely separated vertically. And so what we do is we go into the base data menu, and under levels, we can see that we create some default offsets for each one of these. So that's what we're going to start with on our platform here that we're going to build out. We're going to the base data menu, and we're going to come down to levels. And we're going to have our base level, which might be our street level. We might create one that is our platform as well. So now that we have our platform level, what we can do is we can create different Z offsets. Now, depending on how you want to do this and how you want it to look in 3D, for example, if I'm in 3D mode and I pan down, you can see how we can cut down below the ground. So if I create a level that is negative, it will be below the street surface, so you won't be able to see it through the aerial maps. So that's something that you'll have to decide. So for example, if I put this at negative 30 feet, this platform level, and then I flag these areas as being on the platform level, what we'll see is when I switch into 3D mode, you can't see them when they're above the aerial imagery. But when I pan down below the aerial imagery, you can see how we have now our subterranean levels. So that's one way that you could look at it. You could also just offset the street level up instead, and so everything is visible above ground. It just depends on how you want to do it. And you can actually see that I can move my level offset dynamically in real time, so that way we can kind of establish where we want everything to be, right? So we're at negative. I guess I'm in meters, so I need to switch this actually over to I need to switch my units over to feet because I've been typing in 20 meters. So I'm going to switch my units real quick over to imperial. And so this should actually be negative 20 feet. There we go. That's much more realistic. Well, now that we have our different levels, the question is, how do we connect our different levels within them? And the first thing we're going to look at are stairs, ramps, and landings. So with staircases, these are the default objects that allow you to connect different levels in our network. So let me jump over into here. So instead of having an area connecting these two, I'm going to delete these areas. And what I'm going to do is I'm going to select ramps and stairs, and I'm going to define a staircase. Now, how you define a staircase is very important in terms of the order in which you define it. So if we look on the aerial imagery, we can see we have a staircase here. So I'm going to start at the top, and I typically go in the direction of primary travel. So I'm going to start by drawing the length of the staircase. That's very important. You should always start with the length of the staircase, and then you would draw the width of the staircase. And the reason for doing that is because it always takes from the first place you click to the second place you click. So the starting level in this case would be up here, it'd be our street level, and the lower level is our platform. So now that I have a street level and platform selected, you can see that now I can select the stairway option. If I have the same level, the stairway option is non-selectable. So I'm going to select stairway. We could do rise, and if you're doing like a 7 or an 8-inch rise, that's 0.587, I think, if I remember right. And it'll automatically calculate how many steps you need. So it's taking the difference in our levels, it's dividing it by a rise, a consistent rise. And so you can see now we have ourselves a staircase heading down below to our subterranean level. Once you have one staircase you have defined, we can just copy this over to the other side. Now, if we look on the other side, this side has a landing in the middle. So what I'm going to do is I'm going to define a staircase going in the direction of travel. I'm going to call it a stairway. My rise, I'm going to do 0.588. And then here with landings under our geometry, what we can do is we can define, okay, do we want a straight staircase or do we want a straight with 1, 2, or 3 landings? So if I select 1, 2, or 3 landings, I can define how long each of the flights are, and it will automatically put in a landing for me, and so I can position that landing in other locations. I'm going to bump these up above ground so you can see them a little bit easier. So here we have our 3D staircase with a landing. And again, you can define various different types of stairs and landing combinations. So if we look here, stairs and landings, you could have straight with no landings. You could have straight with multiple landings. You can have angled staircases, U-shaped staircases. The reason you're not seeing any spiral staircases or anything like that is because a stairs just goes from one level to the next. So it's not going to have multiple levels that it stops at. So in this case, if you wanted to create, for example, like a fire staircase, you would create a U-shaped staircase with either 1 or 2 landings, and you would just duplicate it and rotate it multiple times. And then that would give you your staircase. Okay. Now to get a little bit more complex, we can take our staircases and we can give them a moving component and create escalators out of it. Now we have some pre-built escalator details with regard to the railings and movement and things like that. And if you make a flat escalator, well, now you have a moving sidewalk. So we have also moving walkways. If we look at our Farragut West model, the way the Farragut West model flow works is as you come in, These first escalators are the ones that give you access down to the platform, and then the second escalators are for people coming up from the platform. So unlike the stairs, escalators have specific directionality. And so when it comes time to create an escalator, you're going to create an escalator the same way that you would create a staircase. So if I create an escalator right here, for example, you'll just start drawing a staircase as normal. The only difference is you're going to select the escalator option. And this will automatically give you your width with your balustrades, and you can configure your handrails and balustrades and sockets. You can also configure your movement. When we say direction of travel forward, that's going from start to end. Reverse is going from end to start. And the reason we have a reversible option is maybe you have different scenarios, an AM and a PM, where maybe you have a bank of escalators, right? Like this one, where you have 3 escalators, where the left one is always going up, or sorry, the left one's always going down, the right one is always going up, and then the middle one can switch directions, right? Depending on AM versus PM. So in that case, instead of redrawing your whole ramp or your whole escalator, you just reverse the direction that you want to build. So in this case, we just built out a quick escalator. When we hit play on the simulation, the steps will actually automatically move. The other thing you'll need to consider is when you build out your escalator, under movement, what share of pedestrians are going to be walking on the escalator versus standing on the escalator? And if they are standing, are they standing randomly? Are they sticking to the right, or are they sticking to the left? This can really impact the flow of the escalator, the throughput of the escalator, right? So if there's a lot of people just standing there and blocking the way, the flow rates can be limited to the speed of the escalator. Whereas if you have enough room for people to pass by or wind through standing people, then you're actually going to get a lot more flow, especially on escalators moving down. So that's how you can build an escalator. If you have a moving sidewalk, then you'll just draw a ramp just like you would. The only difference is you're going to leave the level the same on both sides, but other than that, you have the same movement and walking behavior and things like that. And now we have our moving sidewalk right here. So if you have something like an airport concourse or something like that. Okay. Finally, for vertical circulation, we have elevators. Now, elevators are a little bit tricky just because when we go to put in our elevators, in this case, our elevators are on this western side. What you're going to do is you're going to define your elevators as rectangles. So essentially, you're defining the elevator shaft. Now here you'll see a door is automatically created. Now we could rotate the whole shaft, or in the list you come down to doors and edge index. You just need to figure out which edge index is which. And so this one, I believe it goes clockwise. So it's a 4. Nope, it goes counterclockwise. So there we go. So 2 would put the door on this edge. Now if you see, actual active levels shows which levels these doors are active on. Now in this case, if we have both active levels on the same edge of the elevator shaft, then what's going to happen is there's going to be a door on the top and on the bottom, and they're on the same side of the elevator shaft. So if we look here and here, we see a door on the top and the bottom. Well, what I can do is I can add in another edge index that's on the opposite side, and I can say, okay, I want one door to be on the platform level and the other door to be on the street level. So in this case, we have a door up here, and then on the other side, we have a door on the other side. Now you also just need to make sure that your area extends to the bottom of the elevator. The final bit is that you'll need to have a waiting area for the elevator. Now the waiting area that we are talking about is a way to call the elevator itself. So in this case, when a pedestrian steps onto this area, that's simulating them pressing the button to call the elevator. So in your pedestrian area, you'll drop it kind of near the elevator door. And then under public transport and elevators, you'll say an elevator is a waiting area, or this area is a waiting for elevator number 1. Here, this is waiting for elevator number 1. So in this case, when a pedestrian steps onto this area, they will push the button for this elevator. Now, you can have multiple elevators that are acting as a bank of elevators, right? And so in this case, when they step onto a particular area, it would call either one of these elevators, just whichever one comes first. So there is a possibility to create a bank of elevators. If you want different elevator groups, you'll come up to lists, pedestrian traffic, and then you see elevator groups right here. You can create different groupings of elevators for different reasons. Maybe you have express elevators and things like that. All right. The final bit that I wanted to talk about was just kind of what type of data do you pull out of a pedestrian network, and why would you pull that data out? So the first one is network performance measures. These are similar to the network performance measures that you might get in Vissim from the vehicle side. Basically, this will show you network-wide measurements. They're useful for things like evacuation planning, for example. You can see time in network and travel time, average travel time. So you can see, you know, as a whole, how long does it take for pedestrians to exit the stadium? It's also good for scenario comparison and statistical analysis. So if you're looking for like an average level of improvement, right, you'll look at the network-wide performance measures from one scenario to the next to give you your level of improvement as a facility, right, as a whole-on facility. What is the average delay for the facility? What is the average density of the facility or travel time? And there's not a lot to it. Basically, what you'll do is you'll just come in and you'll activate your pedestrian network performance measures. And then once you've run the simulation, you'll look at your result list for pedestrian network performance results. And here we can see we have different types of outputs for speeds, stop time, pedestrians entered versus arrived. This means pedestrians that have been inputted into the network versus pedestrians that have exited the network, and then pedestrians actual shows you how many pedestrians are remaining in the network at a particular time. This is especially useful for things like evacuation planning. The next one we look at are pedestrian travel times. So you can throw down travel time markers just like you can in Vissim. So in this case, we've thrown down travel time markers to measure how long does it take to walk from the door to the platform? How long does it take to walk from this concourse onto the mezzanine? So that way we can measure how long does it take to get through the queues and security and things like that. As far as those go, you can see them as here's pedestrian travel time measurements, right? So we have one going down to this platform. We have other ones going to the other platforms. And so you can measure different travel times there. Result lists, pedestrian travel time results. And so here we've taken a lot of time to make sure to name everything so you can see how many pedestrians went to each one of these locations and what was their average travel time in a given time interval. Again, these can be origin and destination, or they could be, I guess I should say, they could be broken up into different subsections of the network. So, what is the travel time from the curb to the gate? And also, what is the travel time specifically through the ticketing concourse? And what is the travel time through the security concourse? The next one is getting more specific. So we look at specific areas in ramp performance measures. So you can look at counts in certain zones. You can look at things like social distancing. We have an output called nearest neighbor distance. So you can see, in addition to just what is the average density of the area, you can look at what is the physical different distance between people. So if you're doing something like, 2020, are you planning for a pandemic or something like that, you could look at what is the raw distance between pedestrians, as well as things like pedestrian delay and experience density. And these are at the area and ramp level. So each one of our areas and ramps will output a specific delay, density, travel time, things like that. And we can look at those in the result lists under area results. We can look at them specifically for our ramps as well. So you can pull out ramp results and see what is the count of pedestrians going up and down different ramps, or delays and densities on various ramps. Finally, we can generate heat maps. So this is a little bit different than the area results, because what Vissim does is, regardless of the area, it subdivides the network into predefined grid cells. And so what we can see is in our Farragut West model, for example, we have a graphic overlay called experienced density. And so here we can see that it's defined grid cells, I think down to 1 foot cells. Let me just double check on that. Pedestrian grid cells. Okay, so 1/3 of a foot for as far as the edge of a square, right? And so each one of these is taking a sub area, and it's measuring that grid for things like density, volume, speed, and the like. And you can take a look and see, where are pedestrians clumping up, where are they moving freely. And this also shows up in 3D, so you can also create nice visuals from a presentation perspective. And you can see where the hotspots are, right? Now, in my experience, hotspots typically will show up in 2 key places. One are at obvious bottlenecks like the top of stairs or security terminals. But one that's not so obvious that people need to consider are things like right angles. Right angles with pedestrian flows typically will create a lot of congestion, because everybody wants to cut that corner. And so the people on the inside typically get boxed out or kind of get stuck and have to slow down. That's why specifically on Farragut, we see that the mezzanine level is built in a very specific way, where you don't see any right angles on the pedestrian movements, right? So the pedestrians come in and they flow down like this, and then when they're leaving, they flow up like this, and those 2 flows are meant to avoid each other, right? And so this is how you can use Viswalk to plan out a pedestrian space to avoid situations like this, where you have a large flow that needs to take a right turn, and then another conflicting flow that also is taking a right turn, and it's kind of a blind corner, right? So this is where pedestrian grid cells can really help. In this case, we're showing experienced density, and what Vissim has an output for is density as well as experienced density. The difference is just there's the raw density of a space, which can be outweighed by the sheer size of the space, right? If I switch over to density, you see there's a lot of blue because it's measuring all these areas for density. But experience density is, what does it feel like to the pedestrians, right? So it only looks at density around a specific pedestrian. So what does it feel like for that particular pedestrian? You can see, for example, here, there's a large difference between the calculated density and the experienced density in terms of where the heat map is, right? So it doesn't feel as dense as it might calculate out to be. All right. And so those are the major components of a Viswalk network. We didn't really talk too much about platforms or crosswalks, but that'll be in an upcoming session. So if you're more interested in things like, how do we manage shared spaces between pedestrians? How do we manage boarding and alighting from public transit? Or how do we manage mid-block crossings with pedestrian beacons? We're going to be doing another Viswalk tooltips in July, where you can get more information on that. We're also doing a virtual training in July for Viswalk specifically. So if any of you are more interested in that, please, again, here's the link, ptv.to/learn. You can go there, check out what events we have coming up in the future.